ready to roll.
All right. So this is CEHV 10. It is Module 12.2, Web App Vulnerabilities and Exploits. Now let's talk about vulnerabilities and exploits for web apps. We can see, and we've already had this conversation when it came to web servers, that web apps sit at the very top of a whole stack of infrastructure, if you will, from the physical environment to the network to the operating system to the web server, the database, any third-party components, and finally the little web app sitting right up here. The web app by itself can be vulnerable, as can all of these other components underneath it. Common web app vulnerabilities can include a number of things. You know, the web apps are going to interact with the user over a network. This gives the ability and opportunity for an attacker to manipulate all sorts of components. We compromise the session, we steal data, we disrupt operations. The web apps communicate in languages that the browsers support, so it'll be HTTP, HTTPS. HTML and JavaScript are typical. They'll run on frameworks like AngularJS, Ruby on Rails, Django, and the like. And they'll communicate with back-end databases using the structured query language, or SQL. General vulnerabilities, mostly it is poor coding, quite frankly. Poorly implemented security configurations or no security configurations in your code. Failings in how the user or the app is authenticated or authorized. Weaknesses to various types of code injection. Weaknesses to cross-site scripting and cross-site request forgery, or clickjacking or file inclusion, or any number of insecure coding practices. Now, we don't expect you, the ethical hacker, to be a coder. I mean, that's a plus. It helps because you can write your own scripts, and maybe you can understand some vulnerabilities a little better. But you should be aware that these things exist. See, as the ethical hacker, you will use tools and your own understanding to test for things. And then when you find vulnerabilities, you get together with the network administrator, the server administrator, the database administrator, the web app developer, the SQL developer, and you work with those people and you point out the stuff that you found, and it's up to them to come up with the fix on a technical level from their perspective that you will test again. So all of these things are general vulnerabilities for web apps. Some common security misconfiguration exploits means that the app has been implemented incorrectly with no protections, so we can therefore exploit these misconfigurations. Some examples. The developer tried to create their own encryption algorithm. They didn't use existing encryption modules. Or they failed to remove legacy content which drags everybody down. Or they failed to remove debug information. Or they're exposing sensitive data because you have files and folders that are unprotected. Or the operating system administrator or the database administrator or the web server administrator didn't patch anything. Or they didn't set any secure values in the web modules. We didn't protect any sensitive data or process it properly on the client side. Or we failed to remove unused admin and default accounts. We can manipulate cookies, and we had a discussion about cookies earlier. So maybe we could modify web cookies in a malicious way. So like, for example, the user is going to some e-commerce site that has the item price actually in the user's cookie. And we grab that cookie and we change the price to, like, instead of $100, it's $1. And then we buy a whole bunch of them. That has actually happened in real life. We modify the cookie to a lower price, we send it back to the server. The server trusts that the cookie is correct because the server originally said, here's the price. It put it in a cookie, and the server is not going to read validate that price. So properly configured cookies should only have session identifiers. They shouldn't include things like prices and stuff that we could manipulate. It's bad enough that we can manipulate session identifiers, but things like price, And that's really, or recipient, or just order details in itself. That's downright foolish. We could do directory traversal, and we saw an example of that in the other module, where we're browsing around the operating system directories, going outside of what directories are being used by the web app itself, and accessing files from locations that are not authorized, that are in the operating system. We could get the web app to backtrack through the directory path up to the root, or the C drive if it's IIS, and go down into a whole other directory that is not appropriate. The apps we could get them to read or execute files in the parent directory. If you can traverse up to the root of the server, then you can go everywhere. So this works really well, this directory traversal, if the app is improperly configured to access parent folders. We might encode traversal text to get around filters. We might double encode to get around strong filters. We just need to be aware of all this stuff. Get your web app developer and point this stuff out to them, and work with them as a team to make sure that these vulnerabilities and potential exploits are not in place. We could have authentication attacks. We could crack credentials. Web servers themselves, of course, have credentials, but so too do databases, and even web apps themselves can have their own credentials. So we can apply all the typical cracking techniques that we would apply to any other OS to the web app itself. If the user has weak passwords, if the developer does not enforce strong passwords, makes it all the easier for us. The app might even have default credentials that nobody thought to change or remove. We might be able to dump hashes for offline cracking. We might be able to hijack sessions. We had a whole module on session hijacking. So when a user makes a connection to a website, they're given a session ID by the web server, which could be in the web token, in the web cookie. It's more likely to be in a JSON object, a JSON web token, but it could be in a web cookie. Either way, we could try to steal the session ID, take over the session, assume their privilege. We can steal it through any number of mechanisms. We talked about them already: sniffing, cross-site scripting, man in the middle, man in the browser. There are a number of ways of stealing those sessions. We could also redirect people away from the legitimate website to a phishing site. But the user thinks it's legitimate. They think it's the PayPal login, and it's not really. We could set up a phony login page that looks real. There are also exploits against a parameter in ASP.NET. So like there's the return URL parameter. So we could have redirect attacks against that. Maybe the user's cookie expires or needs to be generated, or the user is directed to a legitimate site's default login page, and when they authenticate, then they are sent to something totally wrong as specified by this particular parameter in ASP.NET. So the attack process, we could do all these things. Send them a phishing email. Have them click a malicious link. They think they're going to a legitimate logon site. They're going to enter users, their credentials, and they're going to be authenticated. Now, if it's against a legitimate site, they get authenticated, and then in the background, we redirect them to an illegitimate site. Or flip this over. Send them to an illegitimate site, capture their authentication, then redirect them to the legitimate site. Either way, the malicious page looks identical to the legitimate page, and it asks for credentials. And they can both ask for credentials, and the user probably won't think anything of it. They'll put in their credentials to both sites, and then we're stealing those credentials. We're sending the user back to the legitimate site. The legitimate site has already authenticated the user. The user is unaware of the attack. So those are some common web app exploits.